here. So the entrance ticket, describe a time in your life when you predicted the future. For instance, you may have looked at dark clouds in the sky and predicted that it would rain soon, or you may have realized that a certain action would get you in trouble, so you avoided repeating it. How did predictions of the future alter your behavior? And again, this, we could expand it out because I'm taking a little bit of everything. I mean, really, what are we doing when we predict the future? Is we're looking at data or information that we know to be able to make an inference or prediction of what's going to happen. Because I really like, Harley, do you mind if I use your example? Or what you submitted? Do you mind if I use it? Because I know what it is. It's because I like that. Because, I mean, if we're driving along and we hear noises that the car is making, well, we can make a prediction of what is going to go possibly wrong. Because if a car is working at its optimal, it shouldn't be making anything besides the basic engine noises and minor operating, because anything out of effect after that or is making more noise than it should, well, we know what something is wrong, and we can normally predict and get ahead of that. So, well, it doesn't break down, or you end up having 3 wheels instead of 4 because the 4th one decided to go on its own and sometimes go faster than you and go flying by. So, and that's how it changes, because we can actually fix it so it doesn't happen. Or, I think, Jeremiah, you said if we get bad weather, well, we can pull the animals in so that they're out of the weather so they're not going to be in harm. Because again, we can make predictions of what we think is going to happen and then act accordingly and make preparations accordingly so that we are better prepared for it to occur. And that's really what this is for predictions. Learning targets, using new information to make predictions based on a model. Determine the implications of new information based off previous findings of a scientific experiment, scientist or experiment. So a lot of what we're doing in here is that the information that we need isn't going to be directly in the charts. It's not going to be specifically stated, this is the answer. But we can still use the information given to make a prediction of what we think is going to happen. So the answer is still there. We just have to read between the lines to tell us what it is. Now, what is a hypothesis? A guess or prediction of what we think is going to occur, or what we think the experiment will produce. It's a guess. And well, how does an experiment relate to an hypothesis? Well, an experiment tests the accuracy of a hypothesis or whether or not the hypothesis is correct. Because if the hypothesis is wrong, and then try it again. The results of experiments show whether it's correct or not. Now, classmate wants to write an article in the newspaper. Let me get the full description for this here. Imagine one of your classmates has written an article for the newspaper accusing the cafeteria of not providing high-quality food for lunch. She hypothesizes that the high school budget has been too low to afford better food, and the state legislature should allocate more funds to schools for lunches. So, they wrote an article stating that lunch quality is low, the school budget is the cause, and the state should fund schools to better support lunches. Now, the state recently announced additional funding for education centered around promoting student health. So what would our kind of expectation, what would their expectation for this here be? Hopefully better lunches, yes? Or hopefully the funds will be moved towards providing better lunches, yes? Well, would y'all agree that y'all would find them better? They are saying that promoting student health. And I think for the most part, what y'all consider good food and what is considered by the state to be healthy are not quite always in line, are they? No. Because I think they're, for the meats wise, it's about, I think it's the size, for protein is about the size of a deck of playing cards. Yeah, so it's changing how it looks. It might not be better, it could be healthier. Most likely it's going to be healthier, but it might not be as tasty. Let's say another option. Budget cuts mean that certain events, including homecoming, dance, and prom, are canceled. So what can we generalize or expect to happen from this here?
They do upfront funding things like school.
Right? So what did they say? Lunch is very low quality. Why? So what do we expect if they're cutting the budget? Lunch quality will go down. There might be, I mean, some disgruntlement about the fact that events are being canceled, but what do we know? Well, we're saying that low quality food is because of school budget, so if they shrink the budget, the food's probably not going to get any better. Might get worse. And so really what we're doing is we're using what we know or given to make predictions about what we think will happen or occur. Okay. Making prediction. Two scientists, and so this is going to be in your note sheet because I think y'all are all on the page 7.3.1. Two scientists are studying the effects of organic food on health. Scientist A, let me get the highlighter. Okay. Scientist A is studying how eating organic food affects vitamin levels in the subject. Well, that is scientist A. So we can fill that in next to scientist A because scientist A is studying food affects what? So vitamin levels in a subject. So scientist A is trying to see how it affects vitamin levels. While scientist B is studying how eating organic food affects the metabolic rate of his subjects. Now we're also told that scientist A hypothesizes that eating more organic food will increase the vitamin levels in his subjects. While scientist B hypothesizes that eating more organic food will increase the metabolic rate of his subjects. So, scientist A, so if they eat more organic food, what does he expect to happen? Increase vitamins. Expecting to have more vitamins. Scientist B is expecting that organic food will do what? Increase the metabolic rate of his subjects. Digestion. How well you can digest and process food. And it's turning it more into things you can use in less fats or trying to store stuff away. Because if it can't process everything fast enough, it'll store it for later. So having a higher metabolism, metabolic rate metabolism are connected. So they say people who have a really high metabolism can eat a lot and don't seem to gain any weight because they're burning through everything that they eat. And the metabolic rate in your metabolism do slow down as you get older. For most anyways. Now let's see here, making prediction. Suppose studies show that the increased consumption of organic food decreases the risk of disease. How would scientist A explain this result? Yeah, because scientist A is all about what? The vitamins. So if they're not getting sick as much, well, okay, vitamins, higher amounts of vitamins are going to help you stay healthy. Now, suppose studies show that the increased consumption of organic food help people lose weight. How would scientists be expecting this? Increased metabolic rate or metabolism cause for a decrease in weight. And with both of these here, and these here do show up on the ACT, obviously, because we're covering them, but it's using what they're talking about. Especially if they're, why do they want this here? Why are they saying this is true? If we're going off base of what they are talking about, what they're wanting to prove to help us be able to say this. And it's always based off the previous claim. If it's not in their claim, we can't say it's true. So if scientist A was talking about metabolism, well, we can't say it because his whole claim is based off of vitamins. Scientist B can only talk about metabolism. He can't talk about vitamins because we're not going to make the crossover unless they put them against each other. Okay. Well, we're going to look at continuing on with 7.3.1. They give us this here. When an external net force does work on an object, the object's velocity is changed. When work is done on the object over a distance, the kinetic energy of an object is changed proportionally to the amount of work done. Since kinetic energy is related to the object's mass and velocity, and the object's mass is not changed as work is done on it, the object's velocity either increases or decreases. The change in the object's kinetic energy is proportional to the change in the object's velocity. So what are we saying here? Yes. So if I increase the kinetic energy, the velocity is going to increase. And if the kinetic energy decreases, the velocity will decrease because they're always going to be proportional. So suppose studies show that more work on an object can increase the amount of the object's velocity changed. Okay, so they kind of told us that. We didn't even need to actually know how velocity and kinetic energy actually related to each other because they told us right here. Well, I think I went backwards. Yep. Right here. Can increase the amount that the object, okay, apparently it doesn't like me highlighting. There we go. Increase the amount that the object's velocity changes. So it tells us if it increases one, the other increases. Scientist 1 would most likely explain this result by arguing that doing more work on an object, A, B, C, D. So we're saying already that the more work on an object increases, it increases the velocity, yes? So let's look at A. Increases the amount that an object's kinetic energy changes and thus increases the change in velocity. Okay, that looks pretty good. Let's look at B. Increases the amount an object's kinetic energy changes and thus decreases the change in the object's velocity. Well, no, because we said if one increases, the other has to. If one decreases, the other decreases. And it says, suppose that the studies that doing more work on an object can increase the amount. More work, increase, increase. Decrease the amount that the object, so C, decrease the amount that an object's kinetic energy changes and thus increases. Well, again, that's going in opposite directions. One's increasing, the other's decreasing. And lastly, decreases the amount that the object's kinetic energy changes and thus decreases the change in the object's velocity. Okay, that's going in the same direction, yes? But which one's it going to be, A or D? It is A. Because what does this say? Mm-hmm. but it would most likely explain the result by more work because we're talking about increasing up here, yes? So to go along with it, we're talking about increase, because if we're wanting to support the fact that doing more work increases the object's velocity, well, we need an answer that's talking about increasing. Now, if it wanted us to not support, but refute or take away from it, then it would be D. Talk about decreasing. Or having it be the opposite. All right, let's look at the next one here. Following the discussion, so a scientist hypothesized that sunspots peak every 11 years. If this hypothesis is correct, figure 1 indicates that the next peak is in sunspots most likely would occur when? 2011, because where did it peak here? 2000. Well, they peak every 11 years, so the next one after that would have to be 2011, because it'd be 11 years after 2000. Locating necessary information. When answering questions on the ACT, it's important to move quickly, and in order to move quickly, you must know where to find important information, what we're looking for. Because the faster we can find what we're looking for, the better off we're going to be able to find the correct information. Now, choosing who to vote or in a major election, get president, mayor, governor, anything, student council, can be complex. Not so much student council, but the other ones. There are many issues a candidate may have opinions about, and voters often want to choose the candidate whose opinions they mostly agree with. So, we could go through and list the candidates, kind of their discussion points, and like what we're looking for, and we'll go through, you can go through and look them up and find all the different things they are for, they're against, because they've got speeches and debates every which way, and political statements going on that. But there's just several places we can find information about presidential candidates. There are several places on the ACT where you can find clues as how a scientist or experiment might be reanalyzed in light of new information given in a question. So some of the places we can look at it are kind of the passage's background information, where it gives us information about the charts or data. We can also kind of where the description of experiment, tables, and graphs, and the description of the results are different places we can look to find more information. Now, so, okay. So, we'll go on a stop here and we'll finish this up tomorrow.